Now we need the parentheses to say that it's 2 of that whole thing. So 2 of that whole thing. There you go. Now we'll just do that for the entire page, and you'll be really good at writing formulas of ionic compounds. Here we write a formula, we continue writing a formula, and then we translate that to a name. So we've given you over here the name and formula of an ion, and the name and formula of an anion, of a cation and of an anion. So we put the formulas together in a way that balances their charge. So it's a 1 positive with a 1 negative, so we just need one of each. Rubidium cyanide. And then we just write, literally just put the names together. Rubidium cyanide. Same thing here. Calcium phosphate. So we need, to make a neutral compound, we're going to need 3 calciums with, 2 phosphates. 3 calciums would be 3 times 2 is 6 positive charge. 2 phosphates, 2 times 3 is 6 negative charges. But for the name, we literally just put the words together. Calcium phosphate. And then down here, we're going backwards. We're figuring out from the name the formula again. So lithium chloride, we write lithium. We look on our periodic table again to see that lithium is in the first column, so it's a positive 1 charge. Chloride is chlorine in this last column, so it's a 1 negative charge. And those are balanced, so we just put them together. LiCl. Calcium cyanide. Calcium is a 2 positive charge if we look on the table. Cyanide is a 1 negative. So we need to put 2 cyanides with a calcium to make a neutral compound. 2. 2 cyanides, 2 cyanides. Alright, then the next column, now we've gone on to molecular compounds. Molecular compounds, we use the Greek prefixes to say how many things are in the formula. So dinitrogen monoxide. So the reason is because these don't have set charges. With those other compounds, the ionic compounds that we were looking at, the ratio can be determined by the charges, what needs to go together to make a neutral compound. But in molecular compounds, the bonding is done by sharing electrons, and they can combine in lots of different ways. So for this, we have to, you can make all these different compounds of nitrogen and oxygen, so you have to put in the name exactly how many of each one are present. So dinitrogen monoxide means 2 nitrogens, 1 oxygen. Or dinitrogen tetraoxide would mean 2 nitrogens, 4 oxygens. So down here we can go ahead and get started. There's 1 carbon, 2 oxygens, so we can say mono carbon dioxide. We always change the ending to IDE, and if we want, we don't have to write mono in. We could just write carbon dioxide if mono is the very first element. Or if the very first element only has 1, we can leave the mono off the very front of that formula. And that's it. This would be mono carbon, 4 chlorines, tetra chloride. Alright, next up we're jumping to acids. Now acids naming is relatively simple if we already know how to name the anion, the negative ion that hydrogen is bonding to. So there's only 3 basic patterns. For binary acids, or really anything that has the ending IDE, we use the prefix hydro and the ending ic acid. For anything that is an oxyacid that ends in ATE or ITE, then we change the ITE ending to us acid, or the ATE ending to ic acid. So let's talk about how this would be done. And I'll leave this over here so you can see it on the side. while we jump into this worksheet. So this is a binary acid. It's the hydrogen ion combined with this anion. What do we call that anion? That anion is called, fluoride. Fluoride. So that has that IDE ending. That's called fluoride. So when that gets its acid name, we don't mention the hydrogen at all. That's going to be in the name acid. That's what the H plus stands for, is acid. So all we're going to say is we're going to change that IDE ending, like we said over here, to hydroic acid. So if it's fluoride, we're going to take off the "ide" and we're going to put in a prefix hydro and an ic acid ending. How does that work? We're going to say hydrofluoric acid. So we took off the "ide" and we took that fluor part and put it right in the middle. Hydrofluoric acid for IDEs. This one, IO3 with a -1 charge, that anion is called iodate. That's an oxy anion. So if it ends in the ATE ending, it becomes ic acid, iodic acid. Notice the hydro doesn't go on the front of it. The hydro only goes on the front when we have the IDE ending. This one here is BrO2 negative. We call that bromite. Whenever it ends in ITE ending, we get rid of that ending and make it us acid. We change the ITE ending to us acid. Again, no hydro. Hydro only goes on the front when it ends in IDE. And then from there, the rest of them are just mixed up versions of the same thing. So first decide if it's an ionic compound or a molecular compound. This one here is a molecular compound because that's phosphorus and chlorine, two nonmetals together. So for that, we tell you how many of each thing are present. So diphosphorus trichloride. This one here starts with a metal, so it's an ionic compound, and we just have to name the two ions that are combined. This is sodium, and that one's called permanganate. And so on and so forth. This one we've given you some right names and some wrong names that you have to correct. So this formula is zinc carbonate, and you have to figure out what's wrong with this name. In this case, what's wrong with it is zinc is always the 2+ ion. It's never anything else, so you don't need to put this in. So it should just be zinc carbonate. Does not need the Roman numeral. The next one here, what's wrong is this is a binary acid. So with binary acids, this ion here is phosphide, remember? When you have that IDE ending, we need the prefix hydro. So it should be hydrophosphoric acid. And the last page is naming hydrates. Hydrates are when water is absorbed into the crystals. So this is copper 2 plus with nitrate. But there are 6 water molecules that are sort of absorbed into that crystal. Just think of it like a sponge. So we say hexahydrate. So to name these, we have to first name the ionic compound exactly like we otherwise would. So this is going to be mercury 2 nitrate. And then there's just one water attached. So we say monohydrate. And that's it. Happy studying.